Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination.
In today's video, I am going to continue solving KSET 2025 Physical Science question paper. Yes, let us start with the first question. What does the first question says here? Which of the following nuclear reaction is a stripping reaction? According to the definition of stripping reaction, what we have, the best example we have is deuteron and the proton reaction. We have a deuteron and the proton is the example. In that, what happens means deuteron donates a neutron to the target and proton comes out. One thing we need to keep in mind, the proton is coming out from the reaction in the result, that is in the product. So here we can see in the first option only proton is coming out, not in any other options. So option 1 is correct. What does here T represents means it is a tritium and a proton. It is a combination of tritium and the proton. Okay, yes, let us solve the 20th question. The ground state spin and the parity of carbon 13 as predicted by the shell model considering a spin orbit interaction into account is. This question, the same question I have solved in my YouTube channel. You can refer, and you can refer that I even solved the shell model. Also complete video you can see with the examples as well. In this video also I am going to solve. Yes, and we have carbon. They have not mentioned the atomic number, but the atomic number is here 6. Carbon atomic number, it is 6. Okay, carbon 6, 13. So first we need to write proton number. What is the proton number here? 6. And neutron number is atomic mass minus atomic number, that is 13 minus 6, that is equal to 7. So we are interested in only odd numbers, that is unpaired neutron. According to the nuclear shell model, the sequence what we have is the configuration. You can say it is 1s of 1p 3 by 2 and 1p 1 by 2. So the maximum the s orbital can accommodate is 2 neutrons, and the maximum p 3 by 2 orbital can accommodate is 4, and we are left with only one neutron, that is unpaired. So it is occupied by 1p 1 by 2. So it is 1. So we got the answer. Yes, according to the nuclear shell model, J we got to be half. Here this subscript term represents here J, that is you can call it as a angular quantum number or spin also you can call. So J which is equal to half, and we want the parity. Parity is found out by the formula minus 1 to the power of L. What is L here? It is the orbital angular momentum, and we have a p orbital. If we have a p orbital, the L value will be 1 for p orbital. So from the formula what we have, it is minus 1 to the power of 1. So it is again minus 1. So we got the spin to be half, and the parity, it is p to be minus 1. Completely I can write j to the power of p, that is half to the power of minus 1. So coming back to the question, I can clearly say here option C is the right answer. Yes, let us move to the 21st question. If a force F vector is derivable from a potential function V of R, where R is the distance from the origin of the coordinate system, then it follows. So what is the relationship between the force and potential means? We have F vector which is equal to minus gradient of potential V. So this question can be solved by taking options itself. So first I'll do curl of F vector. We will see what we will get the result. So what is the curl of F vector means? On RHS side also I need to do curl of minus gradient of V. V is your potential. So take out the minus sign out of this curl. So curl of gradient of V we got. So from the property what we have means curl of gradient of any scalar function. Curl of gradient of any scalar function is 0. So according to the property, I can say that is curl of f vector which is equal to 0. So option 1 is the right option. Second, we have divergence of f vector, it is not equal to 0, and gradient of v vector, no, it is not equal to 0, and the Laplace equation of v, it is not 0. Okay, they have given it to be 0, it is not equal to 0. So for the 21st question, correct answer is option 1. Let us move to the next question, that is 22nd question. The standard dices with the 6 for two standard dices with 6 faces, which values from 1 to 6 are rolled together, what is the probability of getting a value 8? So two dices we have. So I have written previously the sample space here. The sample space for two dice, it is given below. So from the formula, what is this probability of a event? Probability of event is nothing but outcome of the event divided by set of outcome. Outcome divided by set of outcome, or you can call it a set of all outcomes. Outcome of event divided by set of all outcomes. We got the set of all outcomes, it is 6 cross 6, so it will be 36. Outcome of event, what they have asked in the question, what is the probability of getting a value 8? So on throwing a two dices, we need to get on both faces the addition should be 8. So in the in the sample space, I can tell you people 2 6, one dice if it has 2 and the second dice if it shows the number 6, then it will be some 8. So 1 we got, and 3 5 we got, 4 4 we have, and 5 3 we have, so 6 2 we have. So outcome of the event is 5. Other than this, nothing is possible. So what is the answer? 5 by 36 is the correct answer for 22nd question. Now we will be moving on to the next question. The orthogonality condition for Hn of x is what? They have asked the orthogonality condition for Hn of x. Here Hn of x is a function. It is also the direct question. For this, the answer is the integration from minus infinity to the plus infinity Hn of x and Hn of m of x into e to the power of minus x square dx, which is equal to 2 to the power of n factorial square root of pi into delta of n. This is the correct answer. So from here I can clearly say option 1 is the right answer. Yes. Let us move to the next question. The eigen value of the matrix 3220 or. Yes, let us solve this question. The eigenvalue of the matrix, they have given 3220. To find the eigenvalue of this matrix, first we need to write down the characteristic equation. Characteristic equation is nothing but, I will consider this matrix to be matrix A minus lambda into I, that is determinant of A minus lambda into I, that is equal to 0. What is A here? A is the matrix. Write down here, it is 3220 minus lambda into I is the identity matrix, it is 1001. Okay, that is equal to 0. Now do subtraction. So it is 3220. First we shall multiply. It is lambda 0 0 lambda, taking lambda inside the matrix. After that we can separate this. So that is determinant of 3 minus matrix of 3 minus lambda, 2 minus 0 is 0, 2 2 minus 0 is again 2, 0 minus lambda is minus lambda inside the determinant. So I need to find the determinant of this matrix. How can I find determinant? Multiply these two terms, multiply these two terms in the mid. I need to subtract this 2. Okay, so it is 3 minus lambda into minus lambda minus of 2 2s are what? 2 2s are 4. We need to multiply. So 2 2s are 4, which is equal to 0. Just multiply, take minus lambda inside this. So it will be minus 3 lambda, minus of minus, minus of minus, it will be plus lambda square minus 4, which is equal to 0. On rearranging the terms, we get a lambda square minus 3 lambda minus 4, which is equal to 0. We got the quadratic equation. Solve the quadratic equation. So we have minus 4 lambda square. 1 4s are 4. So here in the midterm we have minus 3 lambda. So I can say here 1 lambda, 4 lambda. Put minus 4, then we get the answer correct. Minus 4 plus 1 is minus 3. So minus 3 lambda will get. So lambda square minus lambda plus lambda minus 4 lambda minus 4, which is equal to 0. Now take the common. Lambda I can take common in this. So what is remaining? Lambda plus 1. Here minus 4 I can take common. What is remaining? Lambda plus 1, which is equal to 0. Now the common is lambda plus 1. Remaining is lambda minus 4, which is equal to 0. 1 by 1 I'll equate to 0. So lambda plus 1, which is equal to 0, means lambda, which is equal to minus 1, and lambda minus 4, which is equal to 0, means lambda, which is equal to 4. Yes, here lambda is nothing but the eigenvalue. We got two eigenvalues, that is minus 1 and plus 4. Let us go back to the slide. The correct option is 4 minus 1 is the correct option.